Okay, so welcome back. So suppose I have the function f of x is 3x minus 5. Graph f and f inverse on the same coordinate axes. So remember, all you have to do is swap the role of x and y. That's how you do this reflection across the line y equals x. So instead of writing y equals 3x minus 5, write x equals 3y minus 5. We just swapped our x's and y's. But now I need to somehow find what this function is, x equals 3y minus 5, solve it for y. Add 5 to both sides, divide by 3, and there we have it. And this is the inverse function. Okay, all we did was we swapped the role of y, we swapped the role of input and output, and then we had to solve for the variable y, which gave us the nice explicit form for the inverse function. So let's verify that those are inverses. So here's the graph of both. This may have been how you started the problem at the very beginning if you paused the video and gave it a try. Find the inverse function. You may have tried just graphing it and drawing the reflection. You could have noticed then that the reflection of this line will just be another line. How do I find the equation of a line? I need 2 points on it. So if I can find 2 points on this line, I can swap their coordinates and get 2 points on this one. And now that you know 2 points on the line, you can determine what line it is, and you should have been able to get this. Okay. So that's not the only way to do it, but maybe that's how you did it to begin with as you tried this graphical approach. The general procedure for finding an inverse function is, step 1, instead of writing y equals f of x, write x equals f of y, and then try to solve for y. If you can solve for y as something with just x's on the other side, then you will have solved for the function f inverse, and then you can double check that it works by doing the composition. I do want to really stress that the right-hand side has no y in it. It's just stuff depending on x's. Okay, so the final video of this section will be doing some examples of this, where we have some functions and we need to find some inverses. I'll do a quick one right now. Okay, so example. Solve, sorry, not solve, let's say find f inverse of x if f of x is equal to, how about, I'm going to write this in a strange way. I'll write 2x plus x plus 1. Of course, this is just equal to 3x plus 1. So the first way we might do this is we say, okay, I had y equals 3x plus 1. So now I swap them. And I write x equals 3y plus 1. And now I try to solve for y. So we have 3y plus 1 equals x. Let's subtract the 1 and divide by 3. And then what you can do is you can say this is f inverse of x, and you can check that f of f and f inverse of f just give me an x. But here's a sort of common error that some people might do. If I had written it as y equals 2x plus x plus 1, because I didn't do that simplification, which isn't required, you don't have to. But then you swap them, and I'd write x equals 2y plus 1, because I replace all my x's with y's and vice versa. Then what I might do is I'd say, oh, I just need to solve for y. So here's a y. If I subtract everything else over, I x minus 2y minus 1, and I'd say, hooray, I'm done. But this is bad because this right-hand side has a y in it. You need that right-hand side to not have any y's in it at all, and that can be difficult, and sometimes, to be honest, it's flat out impossible to isolate y all by itself and not have the only occurrence of y. If there's no y's on the right-hand side and the only y on the left is just a y, you need to get whatever you do to just have a single y and get that by itself, and that's not always doable. But that's what you have to do to find the inverse. In the next video, we'll do some more examples.